All right, so this first one says the region R in the first quadrant, and that's always nice when they restrict you to the first quadrant. Keep it there. Is enclosed by the lines x equals 0, so that's just vertical line, just the y-axis, and the graph y equals 5. So here's our horizontal line, y equals 5, and y equals x squared plus 1. So that's a parabola that's just moved up 1 unit. So we'll have 0, 1, we'll have 1, 2, and then 2, 5. So this is that area in the first quadrant. And my suggestion is erase everything that's outside of that shape. I call these like the tails of the graph. Erase all the tails of the graph so you can focus just on that one shape. And it says, find the volume when you're revolving around the y-axis. So this is going to be a dy problem. This is our ghost shape over here. And so this is the three-dimensional object we're looking at. And so I want you to try to imagine this three-dimensional object. This would be like a cereal bowl that you could not put any cereal in because it's solid the whole way through. Or like a top that you could, like spin on its point. Anyway, I just want you to imagine this three-dimensional thing because it's circular because you're rotating around in a circle. But since it is dy, we need to rearrange this equation. So I'm going to subtract over the 1, and then we're going to square root. All right, so this is going to be pi r squared dy. So just set that up so you don't forget the pi or the squared. So pi r squared, and the radius is going to be right graph minus left graph. The left graph is the axis, so that's just 0. So it's just going to be this graph, which is this square root of y minus 1. And then our boundaries have to be y values since it's a dy problem. So look at your y-axis, it's going to be from 1 to 5. So the squared and the square root cancel out. And then we're going to do the antiderivative. So 1/2 y squared minus 1y from 1 to 5. And unfortunately, we don't get to ignore either of the boundaries. Neither of them is 0. So plugging in 5, that's going to give us 25 halves minus 5. That's upper boundary. And then lower boundary, if we plug in 1, we get 1/2 minus 1. We have to continue fighting our way through this to simplify it down and pick an answer choice. I'm going to factor pi out of this. We'll just have, pi in front of the whole thing. And then distributing this negative, it's going to give us 25 halves minus 1/2. That would be 24 halves, which would be 12. And then we'll have minus 5, and then this will be plus 1. Minus a negative 1 will be plus 1. So 12 minus 5 would be 7, plus 1 is 8, so 8 pi for that. So that is B. All right, so number 2, region in the first quadrant bounded by the graph of y equals secant of x and x equals pi over 4. Okay, so reviewing the graph of secant. Remember, secant and cosecant are those U shapes. You have, a right side up U shape and then an upside down one, a right side up, upside down. I know that you guys missed learning the graphs of the trig functions last year. If you go back into past units, I have a whole folder on missed pre-calc material. All the trig graphs are in there. I made little mini lessons for everything, so you can go and review them real quick. So secant is going to start at 0, 1, and it's going to have asymptotes at pi over 2 and negative pi over 2. And it's going to look like this. Now, then there would be another U shape that's upside down here, and then you'd have another asymptote, and then another right side up one, and then another asymptote, and then another upside down one. It's going to keep doing that forever and ever. All right, so there's our graph of secant. X equals pi over 4. Pi over 4 would be halfway in between 0 and pi over 2. So here's our x equals pi over 4. And so this is the area that we are looking at. And we're going to spin that around the x-axis. So here's our ghost shape down here. So hey guys, what does this look like? I want you to imagine the three-dimensional shape because it's round. Like if I turn it this way, like you guys make up something, be creative, turn on your imagination. Imagine this being three-dimensional. Like what does this look like to you? An anvil. Cool, yeah, I guess. But remember, it's round. anyone have any other suggestions? I'm going to put you in groups later and have you guys talk about these. I want you to be creative, like come up with something that's, to me, it looks like a tree trunk, sort of. Oh, a Christmas tree stand. That's good. I like that. Because understand it is round. So it's like this. This is so hard because we're on the computer. It's like this, and then it kind of like goes down a bit. A bowl from a Chinese restaurant. Okay, cool. I'll take it. I mean, I just want you guys to be creative and come up with something. Anyway, it's round. Is what's going on. I don't know. This direction, it doesn't really mean much to me. I kind of have to flip it the other way. But that's kind of how my brain works. All right. What is the volume of the solid generated? So this is going to be pi r squared dx, because we're rotating around the x-axis. And your radius is upper graph minus lower graph. The lower graph is the x-axis. You can ignore that. That's just 0. Your upper graph is secant. And our boundaries are 0 to pi over 4. All right, so I'm going to just take a moment and rewrite that just with the squared, and that you're squaring secant of x. So it's secant squared of x dx. Hey guys, and I'll get out the flashcards if we need to. I need a trig function that if I do the derivative, I'm going to get secant squared. Like this is the answer. Like who's secant's buddy? Like which one, if we do the derivative, we're going to get secant squared. Good, nice job, guys. Here, let me pull out the flashcard. Here it is. Derivative of tangent gives you secant squared. Perfect, nicely remembered, guys. All right, so when you go backwards, this is going to give you tangents. This is pi times tangent of x, and we're going to go from 0 to pi over 4. So upper boundary minus lower boundary. When we plug in pi over 4 looks like this. Both of the sides of the triangle are root 2 over 2. Now tangent is opposite over adjacent, or y over x, or sine over cosine, however your brain wants to do that. It's this over this, which is going to give us what? If you have the same thing over itself, what are you going to end up with here? Yeah, good, 1. Anything over itself, perfect, is going to be 1. So tangent of pi over 4 gives you 1 and then times pi, so 1 pi. And then lower boundary, I'm going to pull out my unit circle for this. Here's 0 on the unit circle. You haven't rotated anywhere, 0 pi. Again, tangent is y over x. That would be 0 over 1, which is just 0. And then times pi would still be 0. It's just nothing. So your answer to the whole thing is pi. And so that one is C. All right, number 3, we're going to get a calculator for this because look at all the choices. There are all these decimals to take places here. A vase has the shape, oh, this one looks really cool. Has the shape obtained by revolving the curve y equals 2 plus sine of x. All right, we graphed sine of x last class. It starts at the origin and then waves. This one's just been moved up 2 for that plus 2. So instead of starting at 0, I'm going to start at 0, 2, and then it's going to wave. All right, so something like that. So we are going to go from 0 to 5. So here's 0. 5 would be somewhere in between 3 pi over 2 and 2 pi. 3 pi over 2, that's going to be like 4 point something. 2 pi is going to be 6 point something. So 5 is going to be somewhere in between those. So we're going 0 to 5. We're rotating this around the x-axis. So, you know, my art skills aren't real great, but let me try to draw this because this does look really cool. I can like do a good enough job at it. Like here's our ghost shape down here. Do you guys see that? Is that neat? So like, look, it makes a vase. That's sweet. That's cool. I like that. All right. And so we're going to find the volume. So it's going to be pi r squared dx because we're rotating around the x-axis. We're going from 0 to 5. It's always nice when they kind of just hand that to you, 0 to 5. And our radius is upper graph minus lower graph. The lower graph's the axis, that's just 0. The upper graph is this 2 plus sine of x. And we get to just type that in the calculator because all the choices are decimals here. So this is going to be pi integral from 0 to 5, parenthesis, 2 plus sine of x, close parenthesis, squared dx. And we get 80.114. They're going to round up. They always round. So 80.115, and so that one is E. Right, number 4, what is the volume of the solid generated when the region bounded by? Okay, red flag here. It says x equals instead of y equals. So, heads up, this is probably going to be a dy problem. And the line x equals 0 and y equals 5 is rotated about the y-axis. So yeah, going around the y-axis is going to make this a dy problem. So I'm going to make an xy table for this. We'll plug in for y and get x. I usually start with 0, but if you plug in 0 here, you're going to get square root of -2, and you can't square root negatives. You get an imaginary number. Oh, sorry, someone said, why is it 2 plus sine of x for the last question? That's what the equation was that they gave us. It was y equals 2 plus sine of x, because that graph was moved up 2 units. So it was 2 plus sine of x just because that was the equation given in the problem. I'm sorry, I didn't see that until right then. All right, so again, usually I start with plugging in 0, but if you plug in 0, you're going to get a square root of a negative. So I'm going to start with 2. So if we plug in 2, 2 minus 2 gives you 0. If we plug in 3, we're going to get 1. I'm not going to plug in 4. I want to plug in something that I'm going to get something I can square root. So I'm going to do 6. 6 minus 2 would be 4, and then square root of 4 is 2. So let me go ahead and plot those. So 0, 2, 1, 3, 2, 6. And then we have x equals 0, so that's just the y-axis. And then y equals 5. So here is y equals 5. So this is our shape. And again, I usually, erase all the tails of everything, like everything that's sticking out outside of the shape. And it says we're going to spin that around the y-axis. So here's our ghost shape over here, another one of these like solid bowls. And it's going to be pi r squared dy. So looking at our y-axis, our boundaries are going to go from here to here. So that's from 2 to 5. And our radius is right graph minus left graph. So right graph minus left graph is the axis, which you've noticed a lot of the times it is. So our right graph is this. It was already x equals, so we didn't have to rearrange it. It's the square root y minus 2. And then we're going to type this one in the calculator because these are all, decimals to 3 places here. I don't know why they didn't just have us work this out by hand, because the square root and squared cancel, so you could easily do it by hand, but we will type it in and get the decimal. So it'll be pi integral from 2 to 5. And then I'm not going to do the square root and the squared, they cancel. So I'm just going to type x minus 2 dx. Again, I know it says y, just type x. You have an x button, so it's just more convenient. It's like when it says t for time and we still type x. The calculator will never know, it's just a variable. All right, and that gives us 14.137, so that is E. All right, number 5, what is the volume of the solid generated in the region bounded by the graph of y equals 2x? All right, so let's go ahead and graph that. Y equals 2x, that's gonna go through the origin and have a slope of 2, so up 2 over 1. There's y equals 2x. The horizontal line, y equals 2, so that's right here. And the y-axis. So here's our shape, and it is a triangle. So we end up with that triangle. Again, I'm going to erase all the little tails sticking out. And we are rotating around the horizontal line, y equals 2. So I'm going to dot back in y equals 2. That's the axis we're spinning around. Now, whenever the axis gets moved, usually people are like, oh, if it goes around the x-axis, it's dx. If it goes around the y-axis, it's dy. But if we move it, then people get confused. it's like we just took the x-axis and scooted it up a little bit. So this is going to be a dx problem. Again, it's like going around the x-axis, we just moved it up a bit. So I'm going to draw my ghost shape on the other side here. And so it's circular, guys. What does this look like? What did we get? Use your imaginations. What have you got? Remember, it's circular. You have to use your imagination, and it is circular. So what have we got here? Because we actually have a name for this three-dimensional object, or you can make up something that looks like it, but there actually is a name for what this one is. Good, it's a cone. Perfect, a really wide cone, good. Or yeah, like a yeah, or like a yeah, I get what you're saying. But it's a hat you couldn't put on because it's like solid the whole way through. Or I guess you could imagine that it's empty. And an anthill, good. Okay, you guys are there. You got it. Nice. Just some of you guys, I like an anthill. That's good. Or like oh, that makes me think of like an hourglass with like sand falling through the hourglass, and this is the sand falling. Okay, good. I just want you to imagine it three-dimensional. All right, so this is going to be pi r squared dx. Good job, guys. You have good imagination. All right, and our boundaries are going to be x values. So it's going to be from 0 to 1. And our radius is upper graph minus lower graph. So now it's not around the x-axis. We moved it up. So upper graph minus lower graph. The upper graph is this line 2. And then the lower graph is that line y equals 2x. So it is 2 minus 2x. So again, upper graph minus lower graph. For all the other ones so far we did, it was 0 because you were going around one of the axes. But if you move that, then you're going to have another number in there. Now this one we have to work out by hand. I'm going to have to multiply out this 2 minus 2x squared. So if you want to write that out twice, you can, or if you can do it in your head, that's cool. But somehow you have to distribute all of this to each other. So 2 times 2 is 4. The outsides give you minus 4x. The insides give you minus 4x. So that's minus 8x. And then negative 2x times negative 2x will be positive 4x squared. All right, and then the antiderivative, that's going to be 4x minus 4x squared plus 4/3 x cubed, 0 to 1. And you can basically just plug in 1, because if you plug in 0, these are all going to go to 0. So if you plug in 1, you're going to get 4 minus 4 plus 4/3. So those 4's cancel, and this will just be 4/3 pi. And so that one is B. All right, last one. Oh, and this one we just have to set up. We're not going to have to actually work it out or type it in. All right, let R be the region in the first quadrant bounded by y equals tangent of x. Okay, again, reviewing the graphs of the trig functions. Tangent and cotangent are those wiggly graphs. They look like cubic graphs and then have asymptotes, and then it's like another wiggly graph, another asymptote. Again, you could go into that pre-calc folder that I made with all those little mini lessons and go back and look at all the trig graphs. So this is going to have an asymptote at negative pi over 2 and positive pi over 2. It's going to go through the origin and do something like this. And then again, there would be another one of these wiggly things and another asymptote, and then another wiggly thing, and then another asymptote, forever and ever. So that's our graph of y equals tangent. We have the x-axis and the vertical line x equals 1. Pi over 2 is like, I don't remember exactly what it is, 1 point something. So 1 is going to be in between here. 1 is going to be right about there. So here's our vertical line at 1. All right, and we are going to revolve that around the vertical line at 1. So let me erase some of this out of here so that that's not intruding on our picture. So here's our vertical line at 1. And here's our ghost shape on the other side. So this would be like a Hershey kiss. Are you guys seeing that there? Actually, that look exactly like a Hershey kiss. It would be round, and then like this part is kind of curved. Yummy. All right. Now, it's like we just took the y-axis and scooted it over a little bit. So this is going to be a dy problem. So the first thing we're going to have to do is rearrange this equation. Let me write it bigger over here. So it's y equals tangent of x. To get x by itself, you have to anti-tangent, tangent inverse, which you can write as tangent with a little -1, or they wrote it as arctangent. So I'm going to do arctangent. Arctangent of y equals x. This is the equation we're going to be using. And they all say arctangent, so you know, obviously, right? Because that's what all the choices have in them. All right, so it's going to be pi r squared dy, and we're going to have to use y values for the boundaries. So we're going from here to here. Let's talk about this point real quick, this coordinate point here. This is 1. So the x value there is 1. This is on the graph of tangent. So the y value is tangent of 1. X was 1. So the output would be tangent of 1. So if we're doing our boundaries, we would go from 0 to tangent of 1, whatever that is. I don't know. I mean, that's some decimal. Without a calculator, I'm not sure. And then our radius is right graph minus left graph. Right graph minus left graph. So the right graph is 1 minus the left graph is our arctangent of y. And then that's it. They just had you set that up. You could type that in your calculator and get an answer for the volume, but that's all they asked us to do. So now here's where I stumbled a lot of the time because these all look the same to me. All right, pi 0 to tangent of 1. All right, so it can't be either of these. And then it is 1 minus arctangent of y squared. So that is going to be a. But C looks almost identical. They just didn't put the squared in there. So you have to be really, really, really careful.